And now we'll start sharing. So we're going to go over, you can close that. We're going to start going over, we did that already. 2.2. So let's review yesterday. We kind of ran out of, well, I ran out of power. So just a quick review. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So we're talking about a right triangle. And tangent is opposite over adjacent. Okay. 3, 4, 5 triangle is a great one because 3 squared times 4 squared equals 5 squared. So that'll be a nice triangle that you'll want to remember. Sine of theta being the opposite. So if this is my angle theta here, opposite over adjacent, 3 over 5. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. And then these other 3 are just reciprocals of the previous one. So cosecant is the reciprocal of the sine. Secant is reciprocal of the cosine. Cotangent is reciprocal of the tangent. So I guess one way to remember this, you know, S and C, and then this is C and S. So remember, if you think about the letters, they're kind of backwards. So sine goes with cosecant, cosine goes with secant. So, and this was the example we did yesterday. Given that angle theta is an acute angle and the cosine of theta was 5/8, find the tangent of theta. So the cosine of 5/8 is the adjacent over the hypotenuse. We can draw our right triangle, which I didn't do here, but we can figure out that the opposite plus 5 squared equals 8 squared. So you can solve that. Your opposite side is going to be the square root of 39. Therefore, your tangent of theta is the square root of 39 over 5. So that was what we went over last time. And then I think we were starting to talk about these triangles. So any questions about any of this stuff so far before we move on? That was kind of a review of our last class. Okay. All right, so let's talk about some triangles that are going to be very important to remember. In addition to the 3, 4, 5 that we talked about, we've got your general right triangle. So you've got a right triangle with sides A and B. Your hypotenuse is going to be the square root of a squared plus b squared. That's just the Pythagorean theorem right there. The isosceles right triangle, okay, so that means both legs are the same. If we make them 1, so 1 squared plus 1 squared is 2, so therefore your hypotenuse would be the square root of 2. And then we have our 30, 60, 90 right triangle. So this one's kind of interesting because if the short side of 30, so opposite of your 30 is length 1, and your hypotenuse is length 2, then your adjacent side is square root of 3. So, so those can be useful. So let's talk about this middle triangle here, the isosceles right triangle. So, in fact, let me do it this way. So if I have an isosceles right triangle here, so both legs are the same length. Okay. And then this is my right triangle here. Okay. So if I say that this is length A, this is also length A, then we can use the Pythagorean theorem to say a squared plus a squared equals c squared, or r. Sometimes we use r there, so r squared. And so the idea here is if I keep solving this, then 2a squared, 2a squared equals r squared. Okay. And then if, so then I could say that a squared equals r squared divided by 2. Okay. Now the nice thing is if I said a equals 1, which is kind of what we did the first time. Oh, what happened? I didn't mean to open that up. If a equals 1 on both sides, so if this is 1, then 1, in this case, 1 equals your r squared divided by 2. And so therefore, if you take the square root of both sides, I probably should have just left that as 1 originally. In fact, let me back up. We're gonna leave that as 1 squared. So I'm gonna let me get rid of this for a second. Okay, so if a is 1, then this simply becomes 2 equals r squared, right? And so then for r is going to be the square root of simply 2. Okay, so we can figure out the length of this if both of your a's are 1. So r is going to be your square root of 2. Okay. Now, of course, in both cases, this angle here is going to be the same as that angle here. They're both going to be 45-degree angles. Well, 45 and 45. Okay. Now, I'm going to have a chart here in a minute, but 45, if we convert that, 45 degrees is going to equal pi divided by 4 radians. So there are going to be some of these radians that you guys are going to want to remember. So that works out there. Okay, so if I talk then about the sine of either of these other two angles here, so the sine of 45, okay, if both of these are 1, so remind me, here we're going to start picking on people just to make sure you're not falling asleep. We'll start at the top here. How about Brian Larson? So remind me what the sine equals in a generic right triangle.
Sine is opposite over adjacent.
Nope.
Or hypotenuse. I always kid. Yeah. Sorry.
Yeah. Don't mess those up. That's going to be very important for the whole class. That's going to be important. Okay. So if the sine is opposite over the hypotenuse, so in this isosceles right triangle, what would be the sine of 45 degrees?
Is this still for me?
Yeah.
Okay. I guess I'm not entirely sure on how to frame that, if that makes sense.
Okay, so if this is my 45 here, sine of this angle here is going to be the opposite. What's the length? What's this opposite side length?
A.
Yeah, but we said A was 1, right?
Yeah.
So 1 divided by, what's the hypotenuse?
2.
The square root of 2.
Yeah, sorry, the square root of 2.
square root of 2. Now this is where it's really hard. This is where I really wish I had a blackboard. So one of the things here we'll do here, we'll open up a new page. So I've got 1 divided by the square root of 2, but you all know how to rationalize the denominator, correct? We'll pick on somebody after Brian. Cameron Daly, I started to talk to you last time, but we picked on the Cameron with a K. So Cameron Daly, do you remember how to rationalize the denominator?
Do you times the top and the bottom by the square root?
That's correct. So we're going to multiply top and bottom by the square root of 2. So 1 times the square root of 2 is?
Square root of 2.
Square root of 2. Square root of 2 times the square root of 2 is?
Just 2.
2. Okay. And so a lot of times we don't like square roots in our denominator. So rather than write this as 1 over the square root of 2, we'll write the sine of 45 equals the square root of 2 divided by 2. Okay? So if you do any sort of measuring and anything, anybody want to become an engineer in my class? Tayton does, Texas, okay?
Yep.
Chris, you are probably going to use Trig more than anybody. You're going to need to know this really well. I will also just warn you, I was an engineering major for 1 quarter at Weber State. And so one of the things that annoyed me was I was trying to figure out this sine, cosine, tangent, and I had drawn a triangle like this, and you can see even still, even with a computer, I can't draw the line straight. I got the problem correct, but my teacher marked it wrong because I didn't draw my triangle with a ruler, with a straight edge. And I was like, are you kidding me? Anyway, so I changed my major and said, I'm going math instead. So just be careful. You're going to have to write very neatly. Engineers have good handwriting, and I do not. So that's why I'm not an engineer. So anyway, okay. So as we look at this, the isosceles right triangle, you've got 2 45-degree angles. You obviously have your right angle. In radians, that would be pi fourths, and pi halves. Okay. Whoops, didn't mean to do that. Okay, so your sine of 45 degrees is going to be square root of 2 over 2. Your cosine is also going to be square root of 2 over 2. And your tangent of 45 degrees is going to be y over x. So, and I use 1 in here, but a over a, so it's going to be 1. Okay. So these values here, you basically plan on memorizing that. You should know that the sine of, and if I say it as pi fourths instead of 45 degrees, that's always going to be square root of 2 over 2. The cosine of 45 degrees is going to be square root of 2 over 2. The tangent of 45 degrees is always going to be 1. Okay. So so that's the case with an isosceles right triangle. Now, let's talk about a 30, 60, 90 triangle. So that was this one over here. 30, 60, 90 triangle is also useful. So 30 degrees is pi 6th radians, 60 degrees is pi 3rds radians, and 90 degrees is going to be pi halves radians. So you're going to want to get very used to converting between degrees and radians, because we're probably going to, like right now, all of us are used to degrees, but you're going to find the math is a lot easier if you remember stuff in radians. Okay. So so if I take, so this would be a equilateral triangle. So if every side is, so every side is length A, this is length A, this is length A, okay? If I drop a perpendicular bisector down the middle of angle A here, okay, it's going to chop this angle in half. Instead of being a 60-degree angle, it's going to be a 30-degree angle. I've now got a right triangle here, and then because it's a perpendicular bisector, the length of this side is going to be half a. Okay, so as we go down here, we can do the same sort of thing I just did with the isosceles right triangle, and so if we figure out our so our hypotenuse in this case is already going to be a. And so we're trying to find angle or the side h. So h is going to be the height of my triangle here. Okay. So we can use Pythagorean's theorem. A squared plus a over 2 squared equals h squared. And so your h is going to be the square root of 3 over 2 times a. So as we look at this, once again, we can figure out our sine of 30 degrees. So sine of 30 degrees is going to be our opposite over our hypotenuse, okay? So even though I don't have a length here, so a over 2, maybe I should draw this again so that we can go slower here, okay? So I'm going to draw my 30, 60, 90 triangle. Here, I'm going to move this. Oop, didn't mean to do that. I want to keep this here, but I'm going to move it all. Okay. So if I've got a 30, 60, 90 height right triangle, okay? So basically I've split an equilateral triangle in half, okay? So if this is length A, this is length A divided by 2, and then this is going to be our length H, the height of the triangle, which is going to be A times the square root of 3 over 2. Wonder if I can move that over without messing up my triangle. Probably not. Okay, so this makes this angle here. This is going to be your 30-degree angle. Didn't mean to underline that. That's all right. I don't care. This one here is going to be your 60-degree angle. And of course, in this case, this is going to be your right angle. Okay. All right. So we know, as we said before, that I thought I wrote that on there. So let's talk about the sine of 30 degrees in this case. Now we don't necessarily know what A is, but you're going to find out that it's going to all cancel, and so it doesn't really matter anyway. So who did I just pick on? I picked on Cameron, so it must be Cassie's turn. So Cassie, based on this triangle here, this 30, 60, 90 triangle, can you tell me what the sine of 30 degrees is supposed to be?
Mm-hmm.
Do you remember what the sine is with a right triangle? What's the generic formula?
3 over 2 times A, right?
Okay, so remind me, is it opposite over hypotenuse or what is it?
Yeah, opposite over hypotenuse.
Opposite over the hypotenuse, okay. Okay, so the opposite of the sine of 30 degrees in this case is going to be, what's the opposite side? What's the opposite of 30 degrees?
A.
No, that's the adjacent.
That's adjacent. A over 2.
Or actually
Sorry.
A over 2, correct. Okay. And what is your hypotenuse in this case?
A times the square root of 3 over 2.
Now, remember, this is your hypotenuse, and that's your, sorry.
Oh.
This is your adjacent, this is your opposite, this is your hypotenuse.
Oh, A.
So it's going to be A, okay? So your sine of 30 in this case is going to be A squared divided by 2, okay? Now, if A is 1, what would this be? Sine of 30, assuming that A is 1.
Would it be 1/2?
Yeah, 1 squared is 1, yeah, so 1/2, okay? So that's going to be another key thing that we're going to want to remember. So the sine of 30 degrees is going to be 1/2, okay? Now, go back to my notes for a second, make sure I'm following this. I think my notes are backwards. I'll have to fix those. Okay, so let's do the sine of 60 degrees now. Sine of 60 degrees, okay? So remind me, we'll let Cassie off the hook now. Chris, what would be the sine of 60 degrees according to this equation, this triangle?
Excuse me. Yeah, it's going to be A times square root of 3 over 2.
Okay, so slow down. You're going way too fast. Give me the generic formula before we do it. So is it opposite over hypotenuse?
Opposite over hypotenuse.
Opposite over the hypotenuse. Okay, so in
Yeah.
this case, the sine of 60 is going to equal the opposite. So this is my 60-degree angle now. So the opposite is, so let's assume that A is 1. It'll make our lives easier.
Okay, yeah, so it's 1 over, I guess hypotenuse is 1 as well. Oh, so sorry, 1 times square root of 3 over
Right.
2. So
Square root
that'd
of
be
3
square root of 3 over 2.
over 2.
And then you just multiply it by 1.
Multiplied by 1, right? Because our hypotenuse is also 1. Okay, so in this case, the sine of 60 degrees is going to equal the square root of 3 over 2.
Yeah.
Okay, perfect. And then, all right, so I think I need to fix my notes here. This is the sine of 60. Oh, actually, I know what I did. Okay, let's keep going. Okay, so if the sine of 30 is 1/2, could we figure out what is the cosine of 30? So that was Chris that did that one. Corey, Clifford, it must be your turn. What is the generic formula for the cosine?
Adjacent over hypotenuse.
Adjacent over the hypotenuse, okay? So we're using this angle here. What would be the adjacent in this case? So the cosine of 30
would be A, which would be 1 times the square root of 3 over 2.
Over 2
times by
okay.
A, which would be 1.
By A, which would be 1. Okay, so in this case, the cosine of 30 is going to equal just plain square root of 3 over 2. Okay, well done. Let's do the cosine of 60 degrees now. You're in your car again. Is there a reason why you like your car so much?
So what I'm doing is I come to work at 8, I don't start work until 9:30. So I come to my car, I drive here and sit here from 8 till 9:30 to do class and then go to work. And then go back home after work until after 6 and then get all my homework done and then come back and do the same thing.
Wow, that's a tough life. Good on you though. So you're in your car, so you're not late for work. That's good.
Yep.
All right, Graham Johnson, can you help me with the cosine of 60 degrees in this case?
So
It's our 60 degree angle here.
question I have real quick. So is the whole like hypotenuse over adjacent, those like formulas, is that relative to the angle that you're looking at? So the opposite of like the 60 degree angle would be h? Okay.
Right. Yeah. It's relative to the angle you're looking at. Yes.
Okay.
So cosine is adjacent over hypotenuse. I promise you guys are definitely going to want to commit this to memory. We'll do the tangent here in a minute, but.
So it would be a over 2 over a, which would be 1/2 over 1. Is that right?
So the adjacent is a divided by 2, or 1 over. We're going to just call it 1/2. Okay. Times the hypotenuse, which is just plain old a, right? Which is also 1. Okay. Yeah. So the cosine of 60 is going to be what?
1/2.
1/2. Okay.
I had a quick question for you.
Go ahead.
Why are we multiplying once we get the numbers? If that makes sense. I'm kind of lost on why the multiplication.
Oh, you know what? You're right. I shouldn't be multiplying. I should be dividing. It doesn't. You're correct. I don't know why I did that.
Oh, okay. I was just a little confused.
Yeah, I'm sure that was confusing. Good question. You corrected me. Yes, we should be dividing. I'll erase that. Thank you. Oh, I did it up here too, and you waited until now to correct me?
Yeah, I wanted to make sure that's how we did all of them, because I was like, wait a minute, this doesn't seem right.
Wait a minute, why are we multiplying? It says divide. Yeah, correct. Yeah, all these should be divided. Oh, except for, you know what? That messed up my sine of 30, didn't it? Because now when we're dividing by a, okay.
But don't you just end up multiplying
that totally messed up all my math. My stuff was correct. Okay, so now let's do this again. Okay, so thank you. Tell me your name.
Mason.
Mason, I should give you extra credit for correcting the teacher. Okay, so the A's cancel. See, the problem is it's hard to do this. So these A's are going to cancel, right? So the sine of 30 is going to be 1/2. That's still going to be square root of 3 over 2. That's still going to be there, and that's still going to be 1/2. Okay. Yes. Please don't wait so long to ask that question when I'm teaching you guys wrong. That's terrible. Okay, tangent of 30. Let's do that one. We just picked on Graham, didn't we? Jackson, it must be your turn.
Yeah.
So what's the generic formula for the tangent?
That is opposite over adjacent.
Opposite over adjacent. Okay, we're going to do this one right this time. I'm not going to be teaching you guys wrong anymore. Okay, tangent of 30. So we're using this angle here. Okay. So tangent of 30 equals
1/2 divided by square root of 3 divided by 2.
See, then this gets really confusing, doesn't it? Okay, so can you see here that your 2's are going to cancel?
Yeah.
Because we're going to flip that, right? So the 2's going to go on the top. So the 2's will cancel. And I've got 1. So the tangent of 30 is going to be 1 divided by square root of 3, right?
Mm-hmm.
And of course, we don't like to have square roots in our denominator, right? So how would we rewrite that?
So you'll multiply by square root of 3 over square root of 3.
Okay.
That would be square root of 3 over 3.
Divided by 3. Okay. So that works out perfectly. And then, well done. Okay, let's do the tangent of 60 now. And let's see, your name was Jackson. Josue, it's your turn. So Josue, can you help me do the tangent of 60 now? We're using this angle.
Yeah, sure. The 60 is going to be opposite over adjacent. So in this case, it's going to be the square root of 3 over 2 over a over 2, right?
That's correct. Okay. And as we're doing this, we're going to flip this. So the 2's are going to cancel. And the a, as we said, that's a 1, right?
Yeah.
So the tangent of 60 works out to be what?
A square root of 3.
Just plain old square root of 3.
Square root of 3, yeah.
Yep. Perfect. Okay. So, all right. That was a long explanation, but here's the thing. Okay. So you should hopefully see some patterns. Okay. So basically, as we go from the sine of 30, we'll leave that back the way it was. No, that was. Okay. So the sine of 30 is square root of 1 over 2. Sine of 45 is square root of 2 over 2. Sine of 60 is square root of 3 over 2. And then the cosine is just the opposite. Okay. So the cosine of 30 is square root of 3, square root of 2, square root of 1, all over 2. Okay. Now, so here's what I would say. In fact, the math department requires this of me, so it's not just me being a bad guy. You guys have to memorize this chart. And so this is going to be extremely useful. We are going to use this chart all semester. This is on page 137. So it's great because so 0 degrees is 0 radians, 30 degrees is pi sixths, 45 is pi fourths, 60 degrees is pi thirds, and 9 degrees is pi halves. So you'll definitely want to know, you'll just want to be able to look at those and know those. So your sine of 30 is 1/2, sine of 45 square root of 2 over 2, etc. Cosine, we just went over that, is there. Your tangent of 0 is 0. Tangent of 30 square root of 3 over 3. Tangent of 45, we didn't do that one, but it's 1. Okay. Or no, yeah, I don't think we did that one. No, we did that one. It was just a long time ago. I forgot. And then your tangent of 60 square root of 3. Your tangent of 90 is undefined. Okay. And then these are all the reciprocals. And so what I would say, usually I would just memorize this left side of the chart. And then these you can figure out. Just do the reciprocal of everything. So, all right, so we're going to leave this here. And now that we've got this chart, and I know you haven't got it memorized yet, so I'll let you look at the chart. But I want you to find the exact value without using a calculator, okay, of the sine squared of 45 plus the cosine squared of 60. So using the chart, I just picked on Josue. So Cameron with a K, Cameron Ravert, can you tell me, and I've got this nice chart here, what is the sine squared of 45?
Let's see. So would it be that square root of 2 over 2 squared? So
that's exactly right. So square root of 2 divided by 2 quantity squared. Okay, and then we're going to do the cosine of 60 squared, cosine squared of 60. And that is, according to the chart,
1/2.
1/2 squared. Okay. And so the square root of 2 squared is?
4.
Square root of 4 is?
16.
No, it's 2. Square root of 4 is 2.
Oh, I was thinking, my bad.
So 2 divided by, and then 2 squared is 4. So that's 2/4 plus, what's 1/2 squared?
Wouldn't it just be 1/4?
1/4. Okay. So 2 plus 2/4 plus 1/4 equals
3/4.
Which I had there as the answer, and I have a lot better notation, so I just didn't want to give it away. Okay, so that's easier done there. Okay, all right. So now let's do this example. Okay. All right, so this is where your trig comes in very useful. If anybody wants to become a surveyor, you're going to use trig all the time, every day. So you want to know how tall this tree is. You don't have a measuring tape that's tall enough because it's just a really tall tree. You're 115 feet from the base of the tree. The angle you make with the ground is 64.3 degrees. How high is the tree? Here, I'll try to make this a little bit bigger. Okay. So let's talk about this. I just picked on Cameron with a K. Kobe Escalante. Can you help me with this one? How would you figure out how tall that tree is? Kobe, are you here? Turn off your, oh, you did. Can you hear us? Kobe doesn't have a microphone that works, maybe? Okay, we'll move on to Mason. We can't hear Kobe. Mason, can you tell us how you would figure out how tall this tree is?
For sure. So wouldn't you use cosine in this case? Because you know that angle and you're trying to find the hypotenuse, and we have adjacent.
Are we trying to find the hypotenuse?
Oh, no, we're trying to find opposite. You're right.
Yes, so we know we're 115 away. So what would be the best? So would we use sine, cosine, or tangent for this one?
We'd use tangent.
Tangent, okay. So tangent of 64.3 degrees is? Give me the generic formula before we type in the numbers.
Right, opposite over adjacent.
Opposite over the adjacent, okay. So the opposite in this case is going to be?
H,
which is the height of the tree, divided by?
115.
115, okay. So then how would we solve for H?
You'd multiply 115 to the other side.
Okay, so this essentially becomes 115 times the tangent of 64.3 degrees equals your H. And it's as simple as that. Now, I did find out. So here's the interesting thing here. Here I'm going to give you the answer, but then I want to show you something interesting that I found out today as I was doing this, and I was glad I did. Okay, so solve for H. You're going to get 115 tangent of 64.3. So the correct answer is 238.95 feet. Now we could have used the cotangent as well. And so when rounding, the book says use 2 decimals more than the given angle. So since I gave you 1 decimal here, go at least 2 more here. So I'd go 238.952. Okay. Now, I just want to show you this because I don't know how many of you are going to have the same sort of a problem. So watch what happens when I type 115 times the tangent of 64.3. I did not get 238 feet. I got 1,500 feet.
You
also put
typed in
155.
155.
Well, I still got 1,000 feet. And this says the answer is 238 feet. So why do you think I got the wrong answer here in my Excel calculator? So this is something you guys need to pay attention with your calculators. Your calculators will probably be okay, but this is 238 feet. Why did I get 1,000 feet?
Would you click on that formula again in Excel?
That's right here. 115 times the tangent of 64.3.
You gotta put all of tangent in the parentheses. Is that what you have to do?
No.
Okay.
Is 64.3 in radians?
You need it in radians. I was glad I found that out before class. I'm like, wait a minute, what's going on? So how would I convert this to radians really quickly?
Multiply by pi over 180. Yeah.
Exactly right. So if I multiply it by pi and I divide it by 180, then I get 238 feet. Okay. So moral of the story is most of your calculators, make sure you're like, it will do, make sure you know whether you're in radians or degrees. And in Excel, which is a really fancy calculator, it expects your information in radians. so otherwise you'll get a very tall tree. Okay. All right. So I'd like to do another one here. I don't want to give away the answer just yet, except for, I need the picture here. Okay. So avionic equipment measures the distance from a plane to a radar station. So I've got my radar station here, I've got my plane here. If the distance or the hypotenuse from the plane to the radar station is 160 miles, so right here, okay, and the angle to the ground is 30 degrees, find the ground miles from the radar to the point below. That's funny, it says 30. Oh, I think my answer's wrong. I'm gonna have to fix it. But anyway, I think this should be 33 degrees because according to the picture, it's 33 degrees. So I'll change that. Okay, so we're gonna fix my notes because it looks like I did it wrong. So how would we do this?
Well, you'd want to find the angle between the radar and the ground and the plane. Does that make sense? So it says 57 in the picture. So you'd want that. And then you're trying to find x, which is the opposite of that angle. So it'd be, you'd use sine of 57 equals x over 160.
Okay.
And then
we could simply solve for x, right?
Yeah, exactly.
And so x is going to equal, in this case, 160 times the sine of 57, right?
Mm-hmm.
Okay.
Yep.
Are there any other ways we could do this?
Well, you can turn it into radians first.
Well, we could do radians, but let's leave it in degrees for now.
Oh, you mean degrees? Oh, you could do, I guess, figure out.
We could measure it from the
the
radar station, right?
Yep.
What is this angle here if we're measuring it from the radar station?
33.
It's also 33. Okay. So could I use it? So if I use this angle, what would I do?
Cosine of 33.
Equals x over 160.
Also equals x over 160, right? And so in this case, we could say that x equals 160 times the cosine of 33. Okay. Okay, so you can use either a sine to do this, or you could use the cosine to do it, depending on whether you're measuring it from the plane or from the radar station. That makes sense? Okay. Oh, so I guess I did. So I think I did it right here. Let's look at this again. So can do it two ways. If you're measuring from the plane, it's the sine of 57 is the opposite over there. So you're going to get 134 feet. Oh, I didn't think about it. We could also solve. Oh, that's supposed to be from the other one.
Well, technically the unit of measurement in the picture says miles. So instead of feet, wouldn't it be miles?
Oh, it is miles. Yeah. You guys are going to catch all my mistakes on my thing here. Yes, miles. These are miles. I think I think what happened was I copied this from my other one here. For some reason, I put that in there twice. Okay, so yeah, so sine of 57 is, we could get 134 miles, or if we use the cosine of 33, measuring it from the station, that will work. Okay. Now let's do a couple more of these. This is a great example here. An observer wants to know how tall the space shuttle is, but NASA won't let him get near the shuttle. Have you guys ever? I would tell you one of the coolest things. My wife, when we first got married, she had a distant relative that was an astronaut on the space shuttle, and we got to go see a launch. That was one of the coolest things that I've ever seen in my life. And then when I then we came back a week later and we watched it land. So if you can ever have a chance, and I know, well, they don't have a space shuttle anymore, but gosh, that was cool. So anyway, they won't let you get near the shuttle, and in fact, you have to be 3 miles away because supposedly these fumes that shoot off here are toxic. So they don't want to make you sick and die. Anyway, so from where he's currently standing, he has a 27.2 degree angle to the top of the shuttle. When he moves 17.5 meters forward, the angle is now 23.9 degrees. How tall is the shuttle? How would you do this one? This is a tough one, huh? This will be the kind of hard ones that you'll ask me about tomorrow in class. So I wanted to do a good hard one today.
See, one thing I noticed is that the difference between the two angles, the 27.2 and the 23.9 degrees, is a difference of 3.3 degrees.
I think your math was off, but I don't think you want to worry about those two distances.
Okay.
Okay. But let's talk our way through this, okay? So we know, let's talk about this first distance. So we know we're looking at the opposite over the adjacent, right? We don't care about the hypotenuse really.
Right.
Okay. So we know that the tangent of 27.2 degrees, according to my picture here, is going to be what?
Y over x.
It's going to be y over x. Okay. And what's the tangent of 23.9 degrees?
It'll be y over x plus 17.5.
Correct. X plus 17.5. Okay. Now, we can solve either of those equations for y, right?
Correct.
And so let's do the top one. So in this case, if we solve it for y, then we're going to get y equals x times the tangent of 27.2. Okay. Would that be helpful?
No.
Yes.
What? Oh, yeah, it would, actually.
Why is that helpful?
Well, you solved it in terms of y, so you could let y equal x times tan of 27.2, and then you put that in for y for the tan of
right here.
23.9. Yeah.
Perfect. That's exactly what we're going to do. Okay. All right. So essentially, so we've got those two equations. I got them here. So if you solve for one to get there, you got, so x equals, I solved it the other way. X equals y divided by the tangent 2, which is the same thing as y times the cotangent of 27.2. So we can substitute that into this equation here, okay, which gives us the tangent of 23.9. And I don't care whether you solve it for y or x. Anyway. So but this does get a little bit tricky here. Let's think about this for a second. Because still, even knowing that, in fact, let me go back to here. I think this is going to be a little bit easier. Oh, that didn't copy very well. Oh, there we go. That's what happened. Okay, so tangent of 23.9 equals y over y times the cotangent of 27.2 plus 17.5. How would you solve this for y? Because we're going to test your algebra skills, and we're going to make sure you know what you're doing here. And I'm going to throw this out for anybody.
Multiply both sides by the cotangent of 27.2 plus 17.5.
Right. So this is going to be y cotangent, I'll try to capitalize it, 27.2 plus 17.5. This entire thing times the tangent of 23.9 equals plain old y.
And then you could just divide by y on both sides.
No, you don't want to divide by y because y is what you're trying to solve for.
Oh, you're trying to solve for y. That's right. Let's see. We kind of have y on one side.
We got y on both sides. We need to get it on one side.
Right.
This really tests your algebra skills. So at this point, we're going to have to distribute this tangent in here. So this is going to be y times the cotangent of 27.2 times the tangent of 23.9 plus 17.5 times the tangent of 23.9. That's still going to equal y. I put a t there, but that was supposed to be a y. Okay, so I just distributed the tangent through to both of those terms.
Right.
Okay, now what?
You can solve the 17.5 times tangent of 23.9.
Yeah, that's going to be a number, and I'm going to leave it alone for now. That you'll want to do that later, but I don't want to do that yet. So we need to get the y's all on the same side, right?
Right.
Mm-hmm.
Okay. So I'm going to subtract this y cotangent stuff. Minus, here, this doesn't like it, y minus y cotangent. I'm not going to write the whole thing out. Cotangent, we're going to subtract that from both sides. Y cotangent stuff, okay? So essentially this is going to leave me with 17.5 times the tangent of 23.9 equals y minus y cotangent 27.2 times tangent of 23.9. Okay. Now, and remember, basically on the left side of the equals, this is just a number, right? So whatever the number is. Now, how do I get the y all by itself? I'm going to split this up a little bit. 17.5 tangent 23.9 equals, I can factor out my y, correct?
Right.
So if I factor out a y, what am I left with?
The cotangent 27.2 times tan 23.9.
So 1 minus the cotangent 27.2 times the tangent of 23.9. Okay. Now now that I've got that, I can divide by the 1 minus the cotangent, right? Blah, blah, blah.
Right.
Now I've got y equals 17.5 tangent 23.9 over 1 minus the cotangent of 27.2 times the tangent of 23.9. So that's all there is to that. Okay.
Holy smokes.
Yeah. So this really tests, and I didn't explain that really good on my thing. But yeah, so the answer is 56.2993 meters. Just so you know, I'm going to type it in here, 17.5 times the tangent of, let's see here, 23.9. But remember, Excel requires me to put this in radians. So I got to multiply it by pi divided by 180. Okay. So the numerator is that, and then the denominator is going to be 1 minus the cotangent.
You put 11.
Oh, thank you. 1 minus the cotangent of 27.2. Once again, this requires radians times pi divided by 180 times the tangent of 23.9. Once again, this needs to be in radians, so I'm going to multiply that by pi divided by 180. I put all my parentheses in there. And at this point, I take the numerator divided by the denominator, and I get 56.2993. So that's not in my notes, but I know this is all algebra, but it's probably more algebra than you guys are used to doing. Okay. So, but yeah, so basically, summarizing once again, we find the tangent of 27.2, we find the tangent of 23.9, we solve for one equation, either for x or y, and it doesn't really matter which one you do, theoretically. If you can do all of this and do all of the algebra, which I left out of my notes, but I wanted to go over that in class, you should get that the space shuttle is only 56 meters tall. Okay. I know we're about out of time. I do want to go over one. Oh, was that the last one? Oh, I thought I had one more problem. Oh, I guess that was the last one. Okay.
I do have a question though.
The
question that's just like this. Will there be a similar question on a test?
Could be. So remember, I think most of you here are preparing to take calculus. And so these are the kind of awful problems that calculus people have to solve all the time. Now, you don't need calculus to solve this, but yeah, I could put something like this on there.
Okay.
So, and just so you know, as far, maybe we should mention the test a little bit. Hopefully, I put up a second Proctorio thing. I haven't checked today to see if you guys have done that. Basically, our tests are going to be online. You'll need your web camera working, and you'll basically, here, let me go back on camera now. Stop sharing. Okay, so basically you'll say, oh, I don't have any paper here, but this is my paper. It's completely blank. Here's my calculator, obviously. It better not be a cell phone because you can't use a cell phone. Then you'll just take your test. I'm going to try to do a mix of short answer and show your work. And so basically, have you guys had a math class since we've had this pandemic where they've been online? No? So basically, what I'm going to do, the first time I did this, so Proctorio, it's going to record video of you taking the test. My first test, I told people to print it out, which was a bad mistake because when you print it out, Proctorio kicks you out of the test. So do not print the test under any circumstances. It will kick you out. But basically at the beginning, you'll hold up your blank sheets of paper. You'll hold up your calculator so I know that it's a legal calculator. And then you'll take the test. The multiple choice, there'll be a few multiple choice, so those will be easy to grade. And then like a hard problem like the space shuttle one, I'll want to see your picture. You'll just write it on your paper. You'll take a picture, which you can use your cell phone to take a picture of your test. You'll upload it as either a JPEG or a PDF. I would prefer that you save it as a PDF. I've had a lot of problems with people. Sometimes cell phone cameras don't upload things properly. And so please save it as a PDF or a Word document, and then you'll post that as a separate attachment, and then I will grade your paper. So, so any questions for me on the test next week? So part of the reason I had that Proctorio quiz is to make sure that you had everything downloaded, so you're ready for the test next week. So if you haven't taken it, take it late. You can take it as many times. If it asks you for a code, it's not installed properly. And I haven't looked to see how many people. I know one person contacted me yesterday and I had a problem and then we got it fixed. So questions for me? Anything else?
So when we do the test, we're going to have multiple choice and short answers, right?
Yeah, and it's probably going to be more short answer than multiple choice.
Okay.
So
do you want us to like write down the multiple choice answer on the paper that we're going to upload to you? No,
I don't
short answer.
Just the short answer stuff.
Okay.
So the quizzes are easier for me to, I don't have to, for the quizzes, it's way easier to grade if I make a multiple choice, but the test will probably be very little multiple choice. And I haven't verified. I think the math department doesn't want me to give any multiple choice, but that was before the pandemic, so I'm going to try to get away with a few. So, any other questions?
You might have said this and I might have missed it. Sorry. Will the test be timed? About how long will we have?
Yes. Yeah. It'll plan on an hour and a half. Just like, so my plan is, as a general rule, we'll probably cover about a section a day, maybe a little more, maybe a little less, depending on how hard it is. And then, so we'll have a test every other week. So the test will be next Thursday. So next Wednesday is going to be a review day where hopefully I'll have a good review for you. You can ask me anything. We'll just spend the whole day on Wednesday reviewing. Thursday, the test will open up at 8 o'clock. I'll probably give you until 9:30, make it even 90 minutes. And you'll just take it, and then I want you to upload your paper within 15 minutes. So if you have any problems at all, I just taught a statistics class, and the girl submitted her paper an hour late. I was like, why is this an hour late? And she said that she got kicked out, or her power went out or something. Anyway, it was a weird thing. So if anything like that happens, let me know. She called Proctorio, which I'm glad, whatever. I didn't know they had a number, but yeah, if there's anything going wrong, I'll try to work with you. I know there are technology problems, but so please text me immediately. I'd prefer a PDF or a Word document for your posting your photos up there. Please make it legible. Sometimes these are out of focus and I can't read them, or they're tiny, and when I blow them up, it's still hard to read. So just make it as easy for me to read as possible. And if you have any problems, I'll try to work with you. But yeah, the plan is 8 until 9:30, you take the test. Between 9:30 and 9:45, you upload the test, and then I'll start grading them. So we won't meet on a week from Thursday. I'll set the test open right at 8 o'clock. So be there right away, be on time, because it'll end at 9:30. So any other questions?
Nope.
Okay. Well, I got to make a new quiz for you, so I'll get that up. I think I already posted the homework, and it was Chris. You've already started on it, right?
Yeah.
All right, so you got a good head start. So hopefully today's lecture will make that homework a lot easier. But
Yeah.
I'm sure you'll probably ask me about some word problems, so look at those.
Will do.
Anybody quickly, before I let you go, I think I got an email. Somebody said they won't get theirs booked till Thursday. Is there anybody that's going to be longer than Thursday?
I might be a little longer.
That was really robotic, was it? I don't remember whose name that was. Cassie?
It was
Okay. And you can send me an email, because that was hard to understand what you said. But anyway. All right. Well, thanks again, everybody. I forgot to post yesterday's attendance. I'll try to do yesterday and today's today, but I think everybody stayed for the whole thing. So perfect. Just remember, you get an extra point for being on camera. So all righty then. Well, I will let you guys go then, I guess. So see y'all tomorrow. Quiz is due tomorrow. Homework's due tomorrow. And I haven't had anybody tell me about an online homework system. I'd really like to get that. And I don't know if we'll keep up the honor system on the homework, but we'll probably do it until I hear back from somebody. And I might bump up the quizzes to 10%. And I don't know. Do you guys like the honor system on your homework?
Yes.
Yeah.
Because I do want to know that you're doing it. So, all right. We'll do it for this week. And then after that, I don't know what'll happen. So it might change.
Also, would it be okay if we stay on camera and help each other out on homework if we
Oh, do you want to use this room as a study room?
If anyone is up for it.
Yeah, I'll hang up, but if you guys want to stay, that's a great idea. And even if I know somebody has to go to work, if you want, you can join this room at any time. Just, you know, if you want to stick around and exchange phone numbers or whatever, and if you want to say, hey, let's meet at 3 o'clock, you can use this room. I don't have any problem with that. So.
Okay.
Alrighty. Well, I'm going to stop recording, and we'll see y'all tomorrow. And if you want to stick around and talk to each other, that's fine.